Alright, so this is transformations, rotation notes. Like this is our last transformation we have to do. Rotation. A turn around a fixed point called the center of rotation. A turn. For us today, just for today only, our center of rotation will be the origin. We're rotating everything today around the origin. I need y'all to get good at that because next week we're going to be rotating stuff from points not around the origin. You need to be good at rotating around the origin first though. After that, the figure rotates at a specific angle and direction. Angle and direction. Just like with reflections, there's no mapping rule I can give you for rotation up front that'll help you like solve. The mapping rules tell you the answers, just like they did on reflections. Only one that you can see a mapping rule at the beginning for is a translation. But there are rules for the rotations. I'll help you develop them, but I won't teach them to you because you need to just learn how to do it the way I do it. Don't try to remember the rules because it's too much. Symbolic form. So two ways you'll see it written from us: capital R and lowercase r. Same as it is with reflection. You'll notice the difference between the two when we write the stuff afterwards. Reflection, we used to write like R x-axis, or reflect over the x-axis, or R y equals 3, x equals 2, something like that. For a rotation, you're going to see them like this. We may ask you to rotate, and then we put in parentheses here 90 degrees, comma, O. That means around the origin. Telling you to rotate your figure 90 degrees around the origin. Or we could just strictly write R 90 degrees, telling you to rotate 90 degrees. We could do it with a lowercase r too. Say 180 around the origin. Or we could just say rotate 180. The next thing you need to know is how to rotate. There's two different ways we turn. Clockwise. Clockwise, think about how a clock goes, is a turn to the right. You spin to the right. Counterclockwise is a spin to the left. So anytime you spin it to the left, you're going counterclockwise. And also, you might want to star this one. This is the one you'll use majority of the time. Counterclockwise. I'm going to show you why in a second. But, and I'm saying this too, if we don't tell you in the actual problem to go counterclockwise or clockwise, if we just give you a rotation, say rotate 90 degrees, if we don't tell you specifically, always assume it's counterclockwise. So if we don't tell you specifically in a rotation which way to go, always assume counterclockwise. That's the default. Counterclockwise. Down here, just showing you the three rotations in the picture. Rules for rotating counterclockwise about the origin. So they show you the pre-image ABC on the first one, and they show you what a 90 degrees of rotation looks like. It spins into the next quadrant. Counterclockwise, it moves to the left. 180, oh my bad, 90 degrees, we need to write this up here too, is one turn. You'll know what that means when I show you in a second. 90 degrees is one turn. 180, spin it to the left when it's moved two quadrants. This is two turns. 270, move three quadrants. It's just three turns. And we'll never do four turns because that's 360 and it's going to land back on itself. Sliding down, keeping it moving. Alright, so this is us actually doing it down here. Graph and label each figure and its image under the given rotation about the origin. We're not going to use both graphs. The second graph is for me to show you how to use the rule, but I'm not going to teach y'all the rules once again, and I told you why, because I just don't think you'll know. From my previous experience, y'all just won't remember them like that. And honestly, the rules that I'm going to give you for these three, when I do give them to you, after we actually do them by hand first, right there by the computer cart, please. Can't take it no more. The rules that I give you, they only work when you're going counterclockwise. That's the thing too. That's why I really don't want y'all using these, because if they ask you to go clockwise and you use the rule, you're gonna be doing the wrong thing. I'd rather y'all do it the way I'm about to show you right now, the first way. And it's the easiest way. You can always do it. You only just need a sheet of graph paper to do it. Triangle ABC with vertices. Oh, I don't want to read that yet. Let's go ahead to the side. I'm going to draw a little X and Y coordinate out here to the side because I want to do some labeling. Just do a reminder for y'all. Y-axis, X-axis. Let's talk about quadrants. Make sure y'all understand. DJ. Got top left, top right, bottom left, bottom right. Which one is quadrant one? Top left? That is wrong. Top right is quadrant one. It's Roman numeral one. I don't know why I made it that bold. I'm sorry. Go ahead and finish it off, DJ. Quadrant two, where's it? The bottom left. So right here. Oh man, you're wrong. I found your weakness. Yeah, it's top left. I see, I found your weakness. Good. This quadrant two. This quadrant three. Quadrant four. I'm gonna show y'all this for a reason. So these are the quadrants as you move around in them. I'm gonna count them and I'm gonna go around. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Which way is my pen rotating? Counterclockwise. This is why we spin counterclockwise. The quadrants are numbered that way. What's up? Do what you gotta do, man. I don't really care. What? I said the quadrants are counting counterclockwise. Alright, moving on. Graphing this. It says triangle ABC. They want us to rotate it 90 degrees counterclockwise. Graph ABC first. Graph, make sure you label. Especially with rotations. The most important part, say that all wrong, is for you to label first. And don't try to cheat my system either. Everything I'm showing you to do that. We got to the back and kids had to do the last couple problems on their own. All the kids that was doing the stuff wrong was taking shortcuts and not doing everything Mr. Brunson showed y'all how to do on the first couple problems. When you start taking shortcuts, that's when you start taking L's. Do what I ask you to do. Stop doing your own thing. Y'all ain't that good yet. And none of y'all are. So whatever I show you to do on this, do that. Alright. I'm going to talk slow because I want y'all to grasp this concept. The easiest way to do a rotation is to actually do the rotation. I'm going to actually spin my paper 90 degrees counterclockwise. But before I do that, I want to help y'all understand 90 degrees is to the left. We're going to spin our paper to the left. I'm going to get up and show it too because I don't believe y'all going to catch it. Yeah, there you go, Faith. That's it. But if I was y'all looking at my paper this way, facing my paper, 90 degrees is one turn to the left. That's what I'm about to do on the table. So I'm gonna take my paper, turn it one time to the left. I'm rotating it 90 degrees, counterclockwise. Now, this is where kids get messed up at. Hear me out. You rotating your paper. Don't turn your head or don't try to see this any other kind of way. I'm rotating my paper so I can see where my image is going to land. So let me go back. Y'all stay where y'all at. Let me go back though. My image, when it's straight up like this, what quadrant is it in? It's in the first quadrant, right? When I turn my paper just to see how it's going to look, what quadrant does it end up dropping in? 2. And it's showing you that, right? If you turn your paper. Don't overthink this. All I want you to do is keep your paper turned this way and act like it's facing straight up right now. And I want you to write these coordinates down. But keep your paper turned. And I want you to write the coordinates sideways so you don't have to keep turning back too. So out here, just out to the side, it's an open space. I'm going to write A prime, what it should be. B prime, C prime. And I'm going to actually write these coordinates that I see. All I'm doing is reading it based on my paper being turned this way though. I know it's going to end up in 2 and it's going to look like this. I just need to find out where those coordinates are so I can turn my paper back straight and write them. Where would A prime be at based on the way it looks right here? Say it, we got to read it right. What is it? -7, +2, right? Anybody don't see that? We're in the negative direction. 1, 2, 3, 4, 5, 6, 7. Up 2. This is my origin right here. I'm counting everything from the origin. Mark the origin if you can't see it. B prime. Where is that going to be at? -5, 6. C prime? -1, what? -1, 4. Now that I got all 3 points I need, I'm going to turn my paper back straight the way it's supposed to be. That is 4, TJ. What's up with you? Either you're going to plot them points. But before you plot, just go ahead and write them on the lines where they're supposed to be at now. But I write it twice. You're going to write them twice too. Write them on the way the paper's positioned, then rewrite them over here now. So I'm going to say, okay, my points were -7, 2. Put them in where they're supposed to be at. -5, 6. And then -1, 4. And then graph those 3 points up here. -7, up 2 is here. -5, up 6. And -1, up 4. A prime, B prime, C prime.
Teachers and students, please pardon this interruption. The teachers at this time, please release all seniors to the gymnasium. Teachers, please release seniors to the gymnasium. If the majority of your class is seniors, please escort your class.
Shh, don't mess up my video. Yeah.
To the gymnasium to assist.
And here, I got a couple in the other classes.
At this time. Thank you.
Don't mess up my video. They ain't got nothing to do with none of y'all. Back to this. Shh. This is my image after I rotated 90 degrees counterclockwise. This is where it should be. I graphed it over here. Alright? I just turned my paper to see what it would look like over there. And then I turned back straight, then I graphed it over there in that section. Put my prime notations on there. I'm good. Huh? I don't think so. That. On the bottom of that clock right there, Faith. You need that, a second row? You need the one that says practice on top of it. Come here, Faith.
Say what?
Come here real quick. You messing my video all up. So, I hope y'all grasp what I just did. I was thinking kids was good, then we got through the next 2 and they were still thrown off. All we did was turn our paper, look and see how it was going to look, write the coordinates down, turn it back, then graph it. I'm not asking you to do nothing crazy, man. Only other thing I want to do, I really should be advising myself against this, but I'm going to do it anyway. So maybe there might be 1 or 2 kids in here that can actually remember these rules to help them do stuff. I'm trying to think if I want to show y'all this or not. No. I think you don't need to use these. Because you won't never remember them. I'm going to show you why in a second. I'm going to show it to you and I'm going to show you why you won't remember. I'm going to show you. I don't remember them. Alright, be quiet. A was at 2.7. A prime ended up being at -7, 2. B was at 6.5. B prime ended up being at -5, 6. You can look and see how the coordinates flip and you can develop the rule for yourself. If you look, coordinates flipped, and then the original y value changed, the sign on it changed. The rule for a 90-degree turn, this is counterclockwise though, x, y maps to a change in y, x. The reason I don't give y'all these, I tell y'all not to remember these. Let me go back to what we did the other day. Let's look at our reflections. There was 4 different reflections I wrote rules for y'all for. We did the x-axis reflection. Look at that one. X, y maps to x, change in y. That's very close to this, except for there's no flip. I've seen a lot of kids mix these up, and if you get it wrong, you're going to do the wrong thing. This is a reflection over the x-axis. This is a rotation. Very close in what they look like, but 2 different things completely. I'd rather you just know how to do the count for your reflections and how to do the turn for your rotations. Same thing over here, like the y-axis is close to what this one is too, except for you just don't flip. It's just all gets very confusing. I even gave you the rules for y over x. Look at y over x, that's even closer. If you reflect it over that diagonal line y over x, look at the rule for that xy maps to yx. If you forget to do the negative on here, you're going to end up doing a diagonal reflection on your thing instead of a rotation of 90 degrees. These are the issues. This is why I don't want y'all to remember. I can't even remember. It's like 8 of them you have to remember. I don't be remembering all of them. It's just too much. But I do need to show you because you might need to be able to identify it, because maybe they'll ask you on the question what happened to your coordinates. Like, I think that's what happens on the test. Like, we'll give y'all maybe a rotation or something. And we'll say, okay, rotate this image or whatever. And then instead of asking you for the answers of the rotation as far as the coordinates, we'll say what mapping rule happened. But if you're able to compare the coordinates like we just did right here, you'll be able to see how the coordinates change and be able to tell them what rule happened. But you may not be able to remember this rule to be able to apply it. But you'll at least be able to notice it later on. That's what I need you to be able to do. You'll never go wrong by turning your paper, and you can always do that. I'll always provide you with graph paper. You can always turn your paper and rotate your images. Don't try to get stuck in remembering these rules, because you won't remember them. I haven't had a kid yet that's done it. I tried to teach it like that one year, and the kids did horrible on transformations. My kids always do good when they turn paper. Those who are going to try to commit themselves to remembering something that you ain't going to remember, you wasting your time. I'm just telling you. I'm just showing you so you can see them. Don't ever commit to these, because you won't remember them. Once again, I don't remember them, and I'm the teacher. So don't play around with that. Rotate your paper. I'm going to teach you how to turn for everything. Alright, so this was a 90-degree turn. Like I said, we're not doing this one because this one was based off us doing the rules. We ain't doing that. Number 2 on the back. They want us to do a 270 counterclockwise, excuse me. Trapezoid JKLM. We're graphing those points, and then we're going to rotate 270. Other thing I need to say while we're graphing, don't get stuck in thinking all your images will start out in quadrant 1. That is wrong. It's just these first couple that we're doing start out that way, just to get you acclimated to rotations. But your image will not always start in quadrant 1. It can start in any quadrant it wants to, and then you just have to rotate it however they tell you to. Oh, I need a label. J K L M. Whenever you finish, it should look like mine if you graphed it right. And honestly, before you turn paper, I don't want to trick y'all minds or blow y'all minds. You can predict where your image is going to land before you even turn your paper. So you'll know. Like before I even turn, I know I'm going counterclockwise 270. How many turns is this? 3, right? Counterclockwise is to the left. 1 turn is going to take me into quadrant 2. 2 turns is going to take me into quadrant 3. 3 turns is going to take me into quadrant 4. So when I rotate my paper, if I did it correctly, my image should sit right down here. Y'all feel me? Alright, so we're rotating to the left 3 times. 1 turn. 2 turns. I'm upside down now. And then 3 turns. It's a 270 rotation, counterclockwise. And I am in quadrant 4 like I said I would be. Keep your paper turned this way. Don't turn back. Keep it turned the way you got it now. And write your coordinates down. We're going to just label them out here. We'll rewrite them when we turn back straight. Call this J prime, parentheses, K prime, L prime, M prime. Jayla, you got us? Okay. Cariana. I don't know why I was calling you crazy stuff. You got us? Jesus. DJ, take us there, man. J prime, where would it be at? Never mind. Go ahead, Meadow. 4, -3. K prime. She know I'm waiting on her. Yeah, do the rest of them. She gonna do the rest of them. She got them. We got more problems. Louise, you could hold the whole next time. L. One -8, and then M prime. You said it? I couldn't hear you. Say hello. Okay. Yeah, that's done. So I got my points that I need. Now I want to turn my paper back straight. Don't take no shortcuts. Do it full out like I do it. Don't take no shortcuts. You take shortcuts, that's when you start losing. So I got those coordinates. I'm going to write them in over here. Just to rewrite them. Parentheses 4, -3. 4, -6. 1, -8. And 1, -1. After that, I'm just going to graph those, and it should look like my rotation. 4, -3. What? 4, -6. 1, -8. 1, -1. Now, as y'all get better, y'all gonna find ways to speed yourself up. Some of y'all gonna find your own way that you like to do it. Until you get better, you do it my way. Every time you get it wrong, I'm gonna revert you back to my way. Cause you obviously ain't good enough if you keep getting it wrong. You asking me for help. Oh, you can tell me the rule for this one? Okay, give me a sec. You did it right. Should look like that. It should look like a rotation. Some of y'all gonna know when you're going wrong because your stuff gonna end up looking like a reflection when it shouldn't. This looks like a rotation of an image. It looks like if I turn it one more time, it's gonna turn and land back on itself. What's up? Huh? Oh, okay. Let me write up here so we can compare and we can talk about it. So I got two people saying they don't figure out the rule for this one. It's 4 -3 J prime. My K prime ended up being 4 -6. My bad. So you can see what happened to the coordinates. I'm gonna go back to the front so we can write. This is 270. On the 271, so Jayla, what you saw? X, Y, map to what? Y, comma, changing X. Alright. That is how the rule changed on that one. Alright, one more I gotta do for you. Huh? Number 3. Easiest one. 180 is always easy. Triangle XYZ with vertices. Yeah, X, Y, Z. Rotate 180. This one, it didn't tell us which way to go. So which way are we going to default to? Counterclockwise. But on this one specifically, they'll probably never tell you counterclockwise or clockwise on 180 anyway, because 180 is that special one that no matter which way you turn, you're going to end up in the same spot, because it's the halfway one. If I do 2 turns to the left, I'm going to end up the same place I am if I go 2 turns to the right. So it really don't matter if it's counterclockwise or clockwise on 180, but always default to counterclockwise anyway. 3 -2, 6 1, and then 5 -7. X, Y. I cannot make a Y. Z. Oh, my Z look horrible today too. Oh man. X, Y, Z. We are rotating 180. 180 is how many turns? 2 counterclockwise. 1, this will be 90. 2, this will be 180. Your paper should be upside down. This is the 180 rotation. Keep it like that. Now this figure was kind of in 2 different quadrants, so it's all good. Some of your figures will be like that. They'll be split between a couple quadrants. As long as you rotate straight, you should be good. Keep your paper turned this way. We're gonna write our coordinates out here while we got our paper turned. X prime, Y prime, just drop it. Z prime. Anybody got me on these? I don't feel like reading them to myself. Rachel, go ahead. Or I'll get you on the next one. Rachel, go ahead. -3, 2. -6, -1. -5, and what? No. Say it one more time. We went up. -5, +7. It's 0, 0 again. Anybody have any issues with how we getting these points? I want to make sure y'all really understand. So when I leave it to yourself in a second, you go ahead, Cliff. You got a question? I told y'all it's a spatial thing with some of y'all, man. You gotta understand. We flip our page upside down, But we're looking at it as we're thinking like this is our graph straight up right now, though.
So you
And we're just reading points based on this being straight up right now. What?
just making sure. So you just like the normal coordinates you would go like how you would
Give me a
graph-
good question. I don't understand that.
how you would graph them if it was like pretty normally. That's just how you graph them.
That's how you would read these, yes.
Okay.
And once you finish reading them and writing them over here, then you're going to turn your graph back straight to the starting position. And these upside down points are the ones that I want to graph. I'm going to write them over here so they can be straight now. So -3, 2, -6, -1, and then -5, 7. So I'm graphing these on the graph now. -3 up 2 would be here. And that was our x prime. -6, -1 would be here. This was y prime for us. And then -5 up 7 would be here. Yeah, this is the easiest rule here. Out of anyone I'll ever teach you. Alright, if you did it correctly, it should look like a 180 rotation. Make sure you label correctly too. Points should be labeled correctly. Our x prime ended up being -3, +2. Our y prime ended up being -6, -1. I'm sure y'all figured this one out by now too. What happened? Say it louder, Jayla. Don't be. Yeah, the signs just changed. That's literally all that happens for a 180. 180 is the easiest one. All you do is change the signs on your coordinates. So 180, and this counts for counterclockwise and clockwise, the 181. X, comma, Y maps to a change in X, a change in Y. That's the 180 rotation rule. Sliding back to the back. So that's that one. Like I say, it should look like a rotation. It shouldn't look like a reflection. It should look like an object spin on your graph. This next one, just do some setup with y'all on this. So if you look at this next one, rhombus CDEF with these vertices. It says rotate 270 clockwise. Clockwise. Which way are you turning? I'm gonna say to the right, but we saying this now. I guarantee you 4 or 5 of y'all gonna still do rotation 270 counterclockwise. This one is clockwise. You spin it to the right this time. Change your orientation. You spin it to the right. Graph the image first and label it. I'm gonna do that part with you. I ain't doing nothing else though. Graph the image. This image is not gonna be in quadrant 1. That's good for y'all to see too. -5 up 5. Let's see. -1 up 7. -3 up 3. -7 up 1. F. So this is your original figure here. Once you connect the line, so rhombus. I need y'all to rotate that 270 clockwise. Don't try to take no shortcuts yet. Do it the way I did it, so you don't get it wrong. Do it the way I did the other ones. Spin, write your coordinates. Turn it back straight. Rewrite your coordinates, then grab. Handle that, man. Y'all doing these last two. After you do number 4, go to number 5. Should be pretty quick. 5 is clockwise too. You look at it, sitting there confident as you go on your paper. That is 270 counterclockwise rotation you did. I'm talking to you. That's counterclockwise.
Set to the right.
I know, if it wouldn't have landed that. Oh, see, all right, that's one. I got one that don't went counterclockwise. Let's see how many I'm gonna get.